Hello, guys, and let's study the first topic and application of derivatives. And the first topic we would be discussing would be on. Sorry for that. Okay, so the first topic we would be discussing from this would be maxima and minima. So, for example, this is a function, and you have the function. You're taking into consideration this interval. Say this is -1 and 2, and this is the function f of x. So for this interval, the maxima of the function would be the greatest value of the function. The greatest value would be at, according to this diagram, would be at the point 2, and the greatest value would be f of 2. So the maximum of this will be at a point x is equal to 2, and the maximum value will be f of 2. So the maxima of this function lies at a point x is equal to 2. So the definition is f of c. If we consider a point c and that point is greater than f of x in the interval I, then c is the maxima. And when we use the term maxima, it is global maxima. Okay, for example, if this is the function in this interval of say interval -1 to 5, and this is the point c. As you can see, in this interval the least value of the function is at the point c, and the least value of the function is f of c. So c is the minima of this function, and the definition would be for minima as f of c will be less than or equal to f of x in I. In the interval we are considering, the function f of c should be less than or equal to f of x. As you can see, f of c is the least value, it's less than or equal to x. So by we're taking the equality sign is, say if the function is a constant function like this, the least value is the same at all the points in the interval. So this, all the points would be the minimum of the function. So c can be the minimum of the function, and c is less than or equal to f of x, but still, as this satisfies this, c is the minimum of the function. Okay, so this brings us to the extreme value theorem. Extreme value theorem. This theorem states that if function is continuous in a comma b, then function has both maxima and minima. So for example, we consider this function. Say the function is from a to b, in the interval a to b. So what extreme value says is, if f is continuous in this point, f has both a maximum value, as you can see the maximum value is here, and the minimum value is at 2 points. So a function will have a maxima and a minima if the function is continuous in an interval of 2 points. So this is what extreme value says, extreme value theorem says. So the next topic we would be discussing is local maxima.